Welcome, welcome back you all in my today lecture. And my name is Satish Netam. I'm currently studying in ITVHU, and this is a series of PIV series video of PIV. In today discussion, today lecture, we will see some important several components and steps that are in PIV. In our previous video we have already seen these all steps and component, but in this video we will see more what why they are important, what why these important and these steps are important, and try to understand it. So let's start. The particle image velocimetry PIV measurement techniques involve several key components and steps. First one is seedings. We have already know that the seeding is important. Seeding of tracer particle is important, very important in PIV measurement. The tracer particles are introduced into flow. These particles follow the follow the fluid motion and help visualize the flow patterns. Second one, next step is illumination. Light exposure. Under the illumination is light exposure. Tracer particles are illuminated in a specific plane or volume of flow. This illumination occurs at least twice within a short and known time interval. And the next step is recording. After light exposure, we have to record the our area of our interest plane image. So light scattering here, very important is terms is light scattering. The light scattered by the tracer particle is captured using camera. Through camera we are capture the image of our fluid flow. To capture this can involve recording the scattered light on two separate frame or a sequence of frames. यहाँ हम मल्टीपल फ्रेम्स लेते हैं या फिर दो सेपरेट फ्रेम कैप्चर करते हैं टू ट्रैक द ट्रेसर पार्टिकल. नेक्स्ट स्टेप is after capturing image we have to calibrate the image. So establishing relation to determine the relationship between the displacement of particle images in the camera's images plane and the actual displacement of tracer particles in the flow. A calibration process is necessary. Calibration process में क्या करते हैं, जो ट्रेजर पार्टिकल होते हैं हमारे जो फ्रेम जिसमें इमेज में जो फ्रेम जिस फ्रेम पे हमने उसको कैप्चर किया, दो फ्रेम के बीच में उसका डिस्प्लेसमेंट कैलिब्रेट करते हैं. यही जो डिस्प्लेसमेंट ट्रेजर पार्टिकल का डिस्प्लेसमेंट ही क्या होता है हमारे फ्लो का, और जो हमारे जो लिक्विड फ्लो या फिर जो भी फ्लूइड होगा उसका फ्लो का वेलोसिटी फाइंड आउट करने में मदद करते हैं. तो इसलिए हमें ट्रेजर पार्टिकल का जो डिस्प्लेसमेंट है उसका कैलिब्रेशन जरूरी है विद द हेल्प ऑफ कैप्चर्ड इमेजेस. Then other next step is evaluation, displacement determination. In the evaluation process we are doing is we are generally try to find out the displacement determination, because after when we get displacement then we can easily find out the velocity. The displacement of particle image between consecutive light pulses is determined by evaluating the recorded PIV images. PIV इमेजेस को जो रिकॉर्डेड PIV इमेज है उसके थ्रू हम लोग डिस्प्लेसमेंट कॉन्जिक्यूटिव बिटवीन दो इमेज में जो पार्टिकल होगा उसका फाइंड आउट करते हैं. दिस इन्वॉल्व्स कैलकुलेटिंग द वेलोसिटी फील्ड बेस्ड ऑन द डिस्प्लेसमेंट इंफॉर्मेशन. इस पे क्या होता है कि जो कैलकुलेटिंग वेलोसिटी इन्वॉल्व कैलकुलेटिंग वेलोसिटी फील्ड बेस्ड ऑन डिस्प्लेसमेंट का इंफॉर्मेशन का यूज़ करके हम लोग वेलोसिटी फाइंड आउट करते हैं. Then post processing, another step is post processing. तो post processing, in post processing क्या होता है, quality enhancement. Important is quality enhancement. So sophisticated post processing techniques are applied to PIV recording. जो recording होता है images होते हैं, जो भी recording होगा उसको हम लोग post processing करते हैं to enhance their quality. This included detecting and removing any invalid measurement to ensure accuracy. Accuracy के लिए इनमें कुछ अगर invalid measurement होगा उनको हटाना जरूरी होता है. So that's why we need to we are doing the post processing. Complex flow quantities of interest are extracted during this stage. जो complex flow होता है, जो एक्चुअल क्वांटिटीज होते हैं उनको एक्सट्रैक्ट है, जो एक्चुअल मेजरमेंट, जो एक्चुअल रिजल्ट डाटा होता है उनको हमको एक्सट्रैक्ट करते हैं थ्रू दिस स्टेज. हियर इज द सेटअप image of the experimental arrangement for planar 2C 2D PIV in wind tunnel. wind tunnel में हम लोग इसका PIV सेटअप देख सकते हैं. यहाँ पे दो जो पार्टिकल इसका दो कॉन्जिक्यूटिव यहाँ पे डिस्प्लेसमेंट लिया गया है इस वाले एरिया ऑफ इंटरेस्ट का. तो ये 3 पार्टिकल पहले यहाँ थे, फिर डिस्प्लेट होके आफ्टर. तो दिस 2 consecutive frames shows the displacement, showing the displacement of particles. These displacement helping us to determine the velocity of fluid. Here one have laser shows to excited tracer particle, light slit to split the light, the laser beam, and mirror to optics. We can consider to light slit optics and the mirror together as a optics component to scatter to make a sheet, light sheet from the laser. So laser light sheet produce, and then after it falling in our flow with tracer particle. Here the flow direction, here from here to here to illumination in this region. When light when the laser light is incident in our flow, then the tracer particle will illuminated. Then we have image optics. Then the image optics help to filter the scattered and laser light. Generally another purpose we use image optics, and in image optics we are recording this record the image of this area and image plane. We do the image plane. This is the image plane we have captured through the camera. So the particle image velocimetry techniques, tracer particles are introduced in the flow at a non-disruptive location. Non-disruptive location पे इसको introduce किया जाता है. Laser light sheets illuminate a specific plane with a flow, and the particles assume to move with the local flow velocity. यहाँ पे क्या assume किया जाता है, जो tracer particle है वो जो local fluid होगा उसके साथ बिना उसे disturb किए हुए flow हो रही है. The flow velocity are captured in a 2 separate frames by digitally. जो assume to move a local flow velocity, जो velocity होगा उसको हम 2 separate frames के digital camera के थ्रू कैप्चर करते हैं, और तो यूजिंग क्रॉस कोरिलेशन मेथड. इसमें हम लोग क्या करते हैं, क्रॉस कोरिलेशन मेथड का यूज करते हैं 2 सेपरेट कैप्चर्ड फ्रेम से एक्सट्रैक्ट करने, डिस्प्लेसमेंट एक्सट्रैक्ट करने के लिए. द रिजल्टिंग डिजिटल रिकॉर्डिंग्स आर डिवाइडेड इनटू स्मॉल एरिया कॉल्ड interrogation area. We can see the interrogation area, and the local displacement vector for tracer particle between illumination are determined statically. So this is the process which we are we are finding the displacement of tracer particle. The 2 component velocity vector in the light sheet plane is computed. Considering the time delay and the calibration of the image system, modern digital camera enables capturing over 100 PIV recording per minute, and high speed recording in kilohertz range are possible. Evaluation time for recording depending on its size and processing algorithm is typically around a second with a standard computer. For real time monitoring, specialized software algorithms with reduced precision and provide faster evaluation. More advanced PIV setups like astro PIV or volumetric PIV share similar arrangements of illumination, imaging, and recording equipment. The Here the emphasize in the importance of considering technical aspect during experiment planning, setup, and recording, as a error during these phases cannot be rectified during the later data analysis. So we have to take precaution, we have to very aware about these all component. This discussion aims to provide insight into the general aspect of PIV techniques, facilitating the understanding of later described technique solution. In summary, PIV is a comprehensive techniques that uses tracer particles, illumination, and precise recording to visualize and measure fluid flow patterns. Calibration ensures accurate translation of image displacement to actual particles. Displacement and through post-processing enhance data quality for a detailed analysis of complex flow behavior. So this was all about PIV measurement techniques and their important steps and component. In our next video, we will see more about key features of PIV measurement. Thank you. If you like my video, then please hit the like button and subscribe for more similar video.